Hello and welcome to this webinar on the second part in the series on edge computing, co-hosted by a subset of 3GPP market representation partners that you can see at the bottom of the banner. My name is Stephanie Parker and I'm Vice Chair of the 5G Infrastructure Association Pre-Standardisation Working Group. Joining me today is Georg Meyer, Chairman of 3GPP SA TSG. Thank you, Georg, for being with us. Joining us are two other top experts from 3GPP, working very hard to meet the needs of industry verticals and the telecom industry. Punit and Suresh Kachuri, a warm welcome to you both. I'd just like to give you a quick summary, a wrap up of the first part of the webinar on Tuesday, where we looked at industry vertical perspectives. What we saw is a massive impressive number of organizations already embracing the cloud and extensive ongoing standardization work. Much of that is actually collaborative, as we saw and will continue to see this afternoon. One thing that is very important is that because Edge pulls together lots of people and lots of different things, collaboration is an essential ingredient to successful rollout in the marketplace. This will become increasingly so over the coming years as applications move away from a centralized cloud to the edge. So collaboration needs to be right across the ecosystem, including industry verticals, to enable us to have greater clarity on the business and technology aspects, to avoid fragmentation and to enable a return on investment also. So basically, you know, we saw very strong signs from the industry, and this afternoon we'll be looking at what that means from a 3GPP perspective. So I'll introduce you, John, my colleague, introduce himself now, so we can launch the first poll. John, the floor is yours.
Thank you very much, Stephanie. My name is John Favreau. I am a colleague of Stephanie's at Trust IT, and I am a member of the 5G PPP Automotive Working Group, monitoring standardization and developments also in that particular sector. This is about whether you are participating currently in standardization on edge computing. There are several choices here in the 3GPP itself, ETSI, et cetera, et cetera. Please vote. We're very interested in finding out who our participants are and what things they are active in. And I'm sure all the rest of you are interested in finding out who else is also involved from the audience today. So as you can see, the majority, the largest portion of you is not yet involved in standardization on edge computing. So we look forward to you taking away much good information from today's.
Yeah. Yes, and we hope we can find new ways of bringing people on board. And another takeaway from Tuesday's webinar was, in fact, the importance of being involved in some kind of industry or standardization forum to be able to take full advantage of the capabilities of edge computing. I will stop sharing my screen and pass the floor now to Georg, who will tell us give us an overview of the work on edge computing within 3GPP. So thank you, Georg.
Thank you very much for having me and having us from 3GPP for presenting a bit of edge computing and what's going on there in our work. I give a very short intro. We have the real experts here. We have Suresh and Punit, as you said already, who will dive into the details. So I'm just here to give a very quick introduction. So I guess most of you, or most likely all of you in the audience, have an idea what 3GPP is. It's a global standards organization or standards defining organization for mobile communication. We have 700 plus companies. The main thing that you need to know about our work, we organize ourselves in different working groups. The people that are on this call today are from the SA area, from this middle column that you see here. And that is also where currently most of the work on edge computing is ongoing in 3GPP. We are consensus based. That means what goes into a standard can only go there if there is nobody objecting to from the participating companies or delegates. And we are contribution driven. So in order to bring new ideas to 3GPP, you really have to bring written proposals that practically say what to do in the standards or how to change the standards. And also we're working very, very close to the products. Our cycles, our release cycles are 15 to 24 months. And usually you see like within 1.5 years, sometimes even shorter, the things that we defined in our specifications in the market as real products. So where we are at the moment is what we call release 17. That's the third release where we work on 5G. So it started in 15, continued in 16, and now in 17. Not everything we do in release 17 is brand new. Most of the, or many of the issues that we tackle there are continuations from earlier releases. For example, network slicing, non-public networks, also edge computing. Those are issues that we work already since several releases on. We are refining them. We are adding new functionalities there. And that is the way we're working. It's an iterative approach that allows us to come up with early deployments of first basic features and then refining them on and on. And also here on this other column, you see practically what we're trying to do in 5G is really not to only serve the smartphone customer, but the whole range of industries that we assemble under this umbrella of verticals. It's something that we're doing now for several years. I think we're very successful, but we really need the close communication with these industries, with the people that are hopefully here on the call and that are sometimes outside of 3GPP. We have several ways of maintaining these communications, but also what we are very much dependent on is your input. Without your input, we cannot drive our standards in a way that they really satisfy the needs of the market. So when we talk about edge computing specifically, it's a basic functionality now in the 5G core network. It's something that we introduced with 5G. And when you look at the SA arena, which is sort of one of the central columns of 3GPP, you see that it's ongoing in all the groups at the moment. So we go from the requirements over the architecture, which is in SA2, security studies related to edge computing in SA3, streaming architecture extensions, so for media streaming in SA4, management and charging for edge computing in SA5, and then, as we will hear later from Suresh, in SA6, the architecture for edge applications. Our specifications are not made on a green field, so we're not dreaming this up completely all on our own, but obviously we are in close contact with other standards organizations such as ETSI, such as IETF, that handle 5G related issues or that work on the protocols that we are often using to realize these functionalities. And also for edge computing, we're doing the same. I have to say that the presentations on Tuesday that we heard, and I think most of you heard, there were very good education. And although we are in close contact with many of the industry stakeholders, I think there's still a lot to learn and still a lot of ideas how we can widen our focus. Again, I want to say our work is sometimes under very much time pressure. And we really invite those people who have interest in our work, be it in edge computing, be it in any other area that you saw before on the slides, be it in any area that you try to resolve with 5G. Please join our meetings. We are happy to guide you. We are happy to help you to find a way into 3GPP. It's complex, but it's nothing to be afraid of. And it's also a great adventure, which you will see is a very satisfying experience. So once again, please join us, bring us your input. We're really relying on that. And with that, I would like to hand over then. I think first one is Punit, who will show us more about the architecture enhancements for edge computing in the 5G core network.
Thank you, Georg, and hello, everyone. My name is Punit Jain, and I'm SA2 chair, and it's my pleasure to be here. I will briefly talk about the standards development on edge computing in SA2, which is a system architecture and services working group. So as Georg mentioned, edge computing is supported in 5G system architecture since release 15. This slide gives a quick summary of enablers of edge computing in 5G system. So 5G core networks allow a flexible placement of user plane function and can select an optimal user plane function to route the user traffic to the local data network. 5G edge computing scenarios can be supported with multi-homed PDU session, either using an uplink classifiers or multi-homed IPv6 PDU session with branching point. The SSC mode 3, or which is also known as service and session and service continuity mode 3, is a make before break kind of a scenario where no service continuity interruption is supported in the 5G edge computing we using PSA relocation without an IP address change. Application functions can influence traffic routing and steering over N6 interface, and 5G core network provides support to connect to the local area data network in certain areas where the applications are deployed. So most of these scenarios has been supported in 5G system since release 15. And we're going to talk about more what's happening within release 17. So these are the two scenarios where the accessing of an edge application server with or without uplink classifiers or IPv6 multi-homing branching point technology are considered. So both the scenarios where you have support of uplink classifiers and without uplink classifiers are enabled in release 17 going forward. So 5G system considered three connectivity models to enable edge computing. The first one is a distributed anchor point. Here the PSA, which stands for PDU session anchor user plane function, is in a local site that is closer to the UE location. The PSA UPF may be changed, example due to UE mobility and using SSC modes 2 and 3. The second is a session breakout. Here the PDU session has a central PSA UPF in a central site and a LPSA UPF in the local site. The CPSA UPF provides the IP anchor point where uplink classifiers is used. The edge computing application traffic is selectively diverted to the local PSA UPF using uplink classifier or multi-homing branching point technology. The local PSA UPF may be changed due to UE mobility. And the third one is a multiple PDU session. Here the edge computing application use PDU session with PSA UPF in the local site, and the rest of the application use PDU session with the central PSA UPF, as you see in the figure. The local PSA UPF may be changed due to example UE mobility or using SSC mode 3 with multiple PDU sessions. So in release 17, all these three connectivity models are being supported to enable edge computing. So I will now talk about some of the key challenges that has been are being tackled in release 17. So more in terms of what are the problems which SA2 is trying to solve. Since the work is still ongoing, some of these are having a multiple solutions and their work is ongoing to basically settle on some of the solutions. The first one is about discovery of an edge application server. In an edge computing deployment, one application service may be served by multiple edge application servers, typically deployed in the different sites. Before an application starts to connect to the service, it is very important for the UE or the application to discover the IP address of one suitable edge application server so that the traffic can be locally routed to the edge application server via uplink classifier or branching point mechanism. And the service latency, traffic routing path, and user services experience needs to be optimized as well. Also, once discovered, the edge application servers became non-optimized. For example, if the UE moves far away, then the new edge application server may used to be replaced, needs to be discovered to replace the old one, which serves the UE or the application. Also, the release selection of edge application server can be triggered by events either in the 5G system or in the application layer. For example, in the first case, it can be triggered by user plane change initiated by network, such as mobility events like a handover, or failure event, which ultimately is in the 5G S criteria. In the second case, like the application layer, it can be initiated due to an edge application server may become congested or unavailable. So this key issue is trying to address all the problems, and mainly there is quite a big support to use a DNS, and there are various solutions which are being developed for this. So with edge computing being deployed in 5G system, UE mobility and application server relocation needs to be considered when designing solution for optimal deployment of edge solution. For example, as the UE moves across the 5G system, the UE location may change and require the network and the edge to deal with the change of UE location. The 3GPP Release 16 specifications already address some of these aspects, and Release 17 provides an additional improvement. So as you can see here, both the scenarios for the edge relocation with and without UE or E or edge application server IP address change are considered as part of Release 17. With edge computing deployment, it is expected that the set of edge computing functions or edge computing application server running on edge hosting environment will need to interact with 5G system to access 5G's functionality and information, and to provide information to 5G system for provisioning of connectivity services. So as part of the Release 17 study, latency of network exposures needs to be considered. Currently, network exposure mechanism in 5G systems is designed based on NEF, which stands for Network Exposure Function, and other control plane network functions, example AMF, SMF, PCF, etc. For applications deployed in edge hosting environments, the edge application server or application functions may be locally deployed, but in current Release 16, some control plane network functions involved in network exposures are likely deployed centrally to avoid frequent relocations. And this may result in a less than efficient network exposure path in terms of latency. For some network informations to be exposed, a longer exposure latency is tolerable. However, some real network information, example, network congestion condition or real-time user plane latency, can change very frequently. If this information needs to be delivered to application server or application functions timely, undesirable latency may make information obsolete, causing application to adjust their behavior. So this key issue is trying to address how to efficiently provide local application with informations, example, expected QoS on the data path functions. Another key issue which has been looked into is activating the traffic routed towards local data network based on application function request. So key thing is looked into is how to activate traffic routing towards the local data network when SMF does not support the requested DNAI. And in Release 16, there was a work done on ETSN, which stands for Enhanced Topology for SMF and UPF in 5G network. So as part of that, in the ETSN case, both SMF and intermediate SMF do not support the requested DNI in the AF request. And this key issue will also try to address this use case. So this slides basically gives a kind of a high level overview of what SA2 is doing and where SA6 studies are basically complementing each other. SA2 defines a network layer solutions to support UE connectivity with edge application server, while SA6 work is defining middle layer platform for edge computing. So ES discovery is both considered in SA2 and SA6. SA2 is mainly focusing on the solutions via DNS, while SA6 is using ES discovery via middle layer. On edge relocation, SA2 focuses on the user path relocation, session continuity, and coordination with the application function, while SA6 is more looking at an application context relocation at an application layer. Similarly, network exposure, network information exposure from 5GC to AF in SA2 is considered within the network layers, while capability exposure in SA6 is considered from edge enabler server to an edge application server, what you see in the figure below. So both the works are quite complementary to each other. So this is an overall status of the work ongoing. So SA2 has a study on enhancement of support of edge computing in 5GC in release 17. That study is now 100% complete, and the conclusions has been drawn. So based on that, the normative work is proceeding, and the normative work is currently 60% complete. There was a meeting last week which just concluded, and the work is now around 60% complete, and the target stage 2 freeze date is June 2021. And the stage 3, which is protocol, is expected to finish by March 2022. And some of the relevant specifications are mentioned here. Okay, that's all from my side. Thank you very much. And over to you, Suresh.
Thanks a lot, Punit. It was a great presentation trying to explain the support for edge computing at the network layer. And as I think it's a great segue now to move on to what we are doing in 3GPP at the application layer. And I'd like to thank Stephanie and John and their team for giving me this opportunity. It's my pleasure to be here and talk to you about the work that we're doing in 3GPP SA6. So what I would like to cover in my presentation is to give you a brief introduction of the activities in SA6, because I understand, even though the focus is on Edge App, I would like to briefly touch on some of the application layer activities that are sort of related to the verticals. And then I will go a little bit deep dive into the work that we're doing on Edge App, which is the acronym for the work for edge computing at the application layer. Specifically the TS23558, and then speak a little bit about the industry harmonization that we are undertaking, for example, with the work that's happening in ETSMECH and GSMA's OPG, or the Operator Platform Group, and then some concluding remarks. So this is the slide that kind of provides an overview of what we do in SA6. First, I would like to start, with the leadership. Along with me, we have Alan Soloway from Qualcomm and Yuka Weilen from Airbus. I'm happy to have Alan and Yuka support me in the work of the SA6 activities. So SA6 is a fairly new group in 3GPP. So it was established in December 2014. And the primary objective of this group initially was to work on mission critical services. So for a couple of releases, we worked on several standards related to mission critical services, push to talk voice, video and data. And we've seen a lot of good success in this work now being adopted in the markets in several regions, starting with FirstNet in the US, SafeNet in Korea, and projects in UK and Finland and many other countries. So around mid of 2017, looking at the maturity levels of the mission critical services, there was a lot of interest to expand our activities beyond mission critical services. And starting mid 2017 onwards, we've started, we took on several other activities. And if you look at the figure below, right now, all our work is categorized into, I would say, like 3 buckets. Obviously, mission critical services is a very important subject, and we continue to work on that. In addition to that, we are working on several areas that we call as service frameworks. CAPIF is the Common API Framework, which is a unified framework for exposing APIs from 3GPP to the application domain. And then we have SEAL, which is the service architecture that offers common capabilities across verticals. And of course, Edge is a very important topic as well. That's the focus of my presentation today. In addition, what we have is we've worked on and working on several vertical enablers. We have work that relates to V2X, US services, factors of the future, 5G messaging, and so on. So this is kind of a summary of what we do in SA6, and although my focus today is only on the edge computing. So this slide gives you a perspective of the participation that we have in SA6. As you can see, we have a very diverse set of companies or delegates that participate in our activities. And over the last couple of years, I would like to mention that there's been a very good increase in terms of participation, and I would attribute a lot of this increase, in fact, to the edge computing work that we're doing. So if your companies, if the participants, if you're not from one of these companies, I would encourage you to join our group and contribute. So 3GPP edge computing, I will not go into detail. I think Georg gave a very good summary of all the working groups that are working on edge computing. The only thing I would probably say on this slide is, in my view, although the work we've done on edge computing in 3GPP since release 15, I think release 17 is going to be a major release for edge computing, considering the work that's happening in full steam across several working groups. So at the end of release 17, I think we can say that we have a solid foundation for deploying edge applications over 3GPP networks. So let's talk about edge application enablement. So we also refer it to as the edge enabler layer. And so one of the the main requirements that we have seen from application developers is for the ability for the application clients to discover, connect, and connect and switch to the most suitable application server on the edge. So this is the fundamental requirements that application developers look for. And similarly, they would like to have their application servers that are on the edge to integrate well with the underlying 3GPP functionality. So to address this, these two broad requirements, what we have done is to develop a so-called edge enabler layer that provides several capabilities, which I will touch briefly later on, to support the application developers with easy to integrate APIs. So application developers focus more on the applications themselves rather than trying to kind of understand the complexity of the 3GPP system. So as far as the overview goes, so when we started the work on Edge app in SA6, we've had some very fundamental architecture principles that I list here. Application portability is one of them. So the goal was to minimize the application client's logic as well as the edge application server's logic compared to the cloud environments. So when people move applications around, whether it's on the device or on the network, we would like to minimize the changes as much as possible, and our architecture should allow this to happen. Service differentiation. So MNOs are very important to 3GPP networks. So one of the architecture requirement was to enable MNOs to be able to differentiate their services by enabling or disabling the edge computing features. Flexible deployment is about the ability to support multiple edge computing service providers. It's ECSP, and also allow the MNOs to be able to selectively switch the offered service areas within the operator's domain. And of course, the interworking with 3GPP network, so be able to have a tight integration with the underlying capabilities, and Punit talked about several features that SA2 is offering. So we make sure that the capabilities that we expose to the applications are taken care with respect to what's available from the core network. Now, on the right-hand side, we talk about the business relationships, and this is very important because this kind of dictates how the edge applications or edge models are deployed. And here you can see there are four major actors. It's the application service providers who provide the services, and you have the end users or devices you can call. And then we have the MNOs and the edge computing service providers. And we expect that there is agreement between all of these players in order to be able to deploy and consume edge services. One thing to note is the MNO can also be an edge computing service provider if the operator is willing to host the infrastructure for deploying edge applications. If not, then they would have to partner with an edge computing service provider like the Microsofts or Amazons and so on. So looking at the architecture, I have two representations here. One is a typical reference point based representation. We continue to do this as a traditional way of representing architectures, but also we have the service-based representation at the bottom, which is the trend these days, and we believe having a service-based representation is also very useful for the industry. So if you look at the architecture, I start from right to left. So what we have is, first of all, the edge data network, and Punit explained some of the capabilities of what entails an edge data network. So we have edge application servers and the edge enabler servers. So the green boxes here that you see are components of the edge enabler layer. So you have the edge enabler client, edge enabler server, and the edge configuration server. So on the edge data network, we have the edge application server and the edge enabled servers that are located. And then we have an edge configuration server, which sits outside the edge data network as a central entity that offers all the configuration details to the clients that are accessing the edge data network. And on the UV, what we have is the edge enabler client. That's part of the enabling layer. And then you have the application clients that talk to the edge application servers over the top, or using the application data traffic. And then we have, if you see the reference points, edge 7, edge 2, and edge 8. So these are reference points that allow the entities on the network on our architecture to be able to interact with the core network and use their facilities, for example, NEF and so on. So here's a slide on the key features. Starting with the service provisioning. So this is a feature that allows the edge enabler client on the UV to basically receive connectivity information with appropriate network configurations in order to access the best available edge enabling server. So this is a fundamental feature, and probably the first feature or first procedure that a UV would execute when it's trying to connect to a nearest edge. And then we have EAS discovery, or edge enabler server discovery. So this is basically a capability that allows the application clients through the enabler layer to discover the best application server. And Punit did talk about some work that's being done in SA2 in terms of allowing applications on the UV to discover. But here the difference in what SA6 does is, in addition to what SA2 offers, we offer sort of what we call is a rich discovery. So it's beyond IP address. So we offer features such as being able to filter various other characteristics like server capacity and operational characteristics. And also, whether the application server is able to offer service continuity or not, and so on. And then we have the EES capability exposure. So this is a feature or an area that we provide additional exposure capabilities on top of the network capability exposures, because we believe capabilities such as UV location, UV identifier, and user path events are things that application developers would need. So we offer this capability for application developers to be able to integrate to the system. And network capability exposure, we like I said, we integrate with what's offered by SA2. Service continuity is a very important subject because we expect in the edge deployments that UV is always moving around, and we do offer a capability of application context relocation. When UV moves from one edge to the other, and how do you migrate the application context in these situations. We have identified several scenarios on how this could occur, and all that is available in our TS 23558. And last but not the least is the security. This is quite important. So we rely a lot on the security capabilities of what we have in 3GPP, primarily defined by the SA3 working group, and mainly to leverage the 3GPP credentials for authentication and authorization of the edge computing services. So this slide is basically an illustration of how we can integrate the other service frameworks that we have, like the CAPF, SEAL, and some of the vertical enablers into our edge app architecture. This is only illustrative, but if you'd like more details, please refer to our spec, where we provide some guidance in terms of integrating CAPF, SEAL on top of the edge app architecture. So this slide is about relationship with ETSMECH. I understand there is a lot of effort going on in ETSMECH and some other forums. So we have gone an extra mile to sort of position our work in 3GPP in relationship with what's happening in ETSMECH. And as you can see, this is sort of a harmonized architecture between 3GPP Edge app and ETSMECH. So the green. So overall, my summary of this harmonized architecture is, there are areas that are 3GPP specific. For example, the support at the UV, integration with the core network, and the ECS, which is the configuration server. And when you look at the blue areas, these are areas where I think there are a lot of synergies, looking at the EAS and MEC application, and EES and the MEC platform, and the reference points that are connecting them. And this is where I think there is probably some work to further harmonize and allow both architectures to coexist. And the gray box is about the network management. I think HC also has done a lot of work here. However, 3GPP SA5 is also looking at this, and I expect some convergence also happening in this space. And for those of you who are not aware, there is a detailed white paper that is published from HC. If you would like to understand more details about how the harmonization between the ETSMECH architecture and 3GPP architecture would look. And next is the slide on GMAOPG. As I mentioned, GSMA operator platform group is actively working on defining use cases and requirements for telco edge computing. And here we also describe, and it's in our specification, where we show how the edge app architecture maps to some of the reference points and functional entities within the GSMAOPG. And I'm glad to say that there is a lot of alignment when you look at the UNI and also the cloud resource and network resource management, and the east-west bound interfaces, EWBI. Which has to deal with the federation of edge computing platforms. Again, have a link here. If you're interested, you can have a look at it. So in conclusion, I want to kind of say that, again, as I said, edge computing is a major feature of release 17. And I look forward to, seeing through this release. So we have a solid foundational platform for edge computing. And also, I want to say that the capabilities that we are defining in SA6, SA2, and several other groups will offer native support for edge computing in 3GPP networks. So this is very critical. So we want to make sure that there is a native support for edge computing that you can rely on. And I did talk about architecture models and flexibility that we offer through our architecture, and some of the advanced application features like context relocation and EAS capability exposure, APIs, and also the service-based architecture. And also the synergies that we are seeing with the work that's happening in the industry in this space. So that's all from me. And if you have any questions, please feel free to reach out to me or include them in the chat window. Thank you.
Thank you very much, Suresh. And gentlemen, you've done brilliantly well on the timekeeping. We're a little bit ahead, in fact. many congratulations on the work you're doing. I'll now pass on. You can take a breather because we're going to do another poll now. So the floor is yours, John.
Yes, thanks very much, Stephanie. Yes, we'd like to do another poll now to give you a chance to catch your breath. How important do you think coordination is on edge computing standardization? We have seen this, we have seen some examples in the deep dive today, and we saw quite a bit of discussion on this in the first webinar 2 days ago. So we would like to hear also your voice today and how you see this. So of course, we're happy to see that everybody involved thinks that it is vital, or at least very, very important. And there's a small percentage who do not think it's needed, and it'd be interesting to hear their opinions on why not.
Yeah, thank you very much, everybody. So we'll now bring back our three chairmen for the interactive panel discussion. I'll ask the first question, starting with Georg. So how do you see the standardization landscape evolving with regard to the growing market demand?
Yeah, thank you. First, just as a quick injection, I see a question in the chat asked. I think we could also take this publicly, maybe after we answered the other questions.
Yeah.
But on your question now, I mean, obviously, there is a lot of work going on in the whole, let's say, sub-ecosystem that we have for Edge now. People who think of applications or managing the edge computing, the different layers that we saw now in Punit's and in Suresh's presentation, they attract different people with different mindsets. And mostly what we see at this moment, I think, is, as we also have seen on other topics such as slicing in the past, is that people think, oh, this technology is really coming up. What can we do with it? For example, in the automotive, in the health sector, in the manufacturing sector, and so on. How can this serve us, or how can our applications make use of that? And there, I think we are still at a starting point. We always have this, that when we start developing such technologies in 3GPP with a stronger focus, as we do now in release 17, with a very strong focus on edge computing, as we saw, that usually leads to a market impact then let's say 2 years, 3 years down the road, when people really get aware, wow, that's there and we can use it. So I think this is really just starting, and the people in ETSMECH and in 3GPP and in the other organizations, they are the first ones looking at this still at this moment. This is very positive. On the collaboration side, the advantage is that also what we saw on Tuesday in the presentations is that to all these organizations that we saw there, as ETSI, as 5G, ICIA, automotives, and so on, 3GPP by itself has already very strong relationships. And it's maybe at this level that we are working also, especially when you look at the two presentations that we just saw, these the relationship between the organizations is important, but maybe it's even a bit secondary. What we need is the experts in the room. And that I'm confident we have at this moment. We have the experts from the different companies who are aware what's going on in ETSMECH, what's going on in 5G ACIA, what are the requirements from the automotives, and so on. We have these people also participating in the relevant 3GPP groups, be it on the APIs, be it on the implementation in the core system. And therefore, the exchange sort of is there naturally, at least to a large extent. And we see this also by sort of these organizations, there is a certain amount of communication, but it's not like overwhelming. So practically we see that we're working in concert and we're really trying to fulfill each other's needs. A bit of a side topic on that is the whole management issue that we have in SA5, where we know there is already a very specific and good collaboration between the related ETSI and the 3GPP work. So these groups are used to collaborate since many, many years already on different topics. So there's also security that we're really looking at the whole picture. Now, nevertheless, if people come up with new ideas in different standards forums or also collaboration forums of industries, as I said before, the main path to make us aware of this is really to participate in our meetings. You don't have to subscribe for like a lifetime to participate in 3GPP, but we have channels where we welcome requirements, and that is sort of the way to make us aware of this. And I'm, as I said, on the landscape as it is now, it's great to see it is evolving. And it's also great that it's working sort of coordinated, or at least in strong communication amongst each other.
Thank you very much, Gail. I don't know if Punit and Suresh would like to add anything to that.
I think Georg covered it very well. Thank you.
Okay, thank you. So John will go on to the next question.
Yes, thanks, Stephanie. A question has just come in, and it's about the use of AI in Edge. Now, this was something that we also saw talked about quite a bit in the first webinar. So, Punit, I'd like to ask you to start with, how does artificial intelligence fit into this landscape in terms of being, let's say, a building block for edge computing?
Thank you, John. Let me just first take a quick moment to thank SA2 rapporteur Nihui from Huawei, who has helped me in some of my presentation. Some of the nice figure you see in my presentations actually has been brought by SA2 rapporteur Nihui, and I forgot to thank him, so I just wanted to take a quick moment to thank him for helping me with that presentation. Now, coming to your question, I think that's a very interesting question. Basically, the edge computing enables to locate resources near the consumer to provide low latency and high data volume, and we all understand that. And in order to support tremendous service application running on edge computing efficiently, 5G system needs to consider edge computing deployment and hosted application and service characteristics. So artificial intelligence here plays an essential role in optimizing and automating several edge computing use cases. One such use case which is been looked in 3GPP and in SA2 specifically is how to optimize user plane for edge computing. I mean, there could be many other use cases, where the edge computing can help in essentially optimizing and automating, but I will just focus on this for now, and then I will generalize it a little bit. So for optimizing user plane in edge computing, the SA2 is looking into what kind of analytics could be exposed to an application function and internal network functions to improve user plane optimization and support edge computing operations efficiently. Other things can be looked into is what kind of data should be collected by a analytics function. So SA2 has defined a network data analytics function as part of release 16, mainly to provide analytic informations to various use cases. And one such use case also would be an edge computing. And last but not least, how to assist user plane path optimization considering data network characteristics. So NWDA, which is a network data analytics function, can provide a service experience, and service experience refers to a quality of experience as established in a service level agreements during onboarding of devices. It can be either like a MOS or video MOS or customized MOS, which is defined by ITU specifications. What 3GPP has done is in terms of enabling or edge computing scenarios for optimizing user plane, path optimization by enhancing NWDF to provide service experience analytics per user plane path. And this can be basically provided to a session management function to assist user plane optimization for edge computing, or to application functions to determine if the DNI relocation is required, or whether service parameter adjusting is required, or this service experience can be also provided to determine the best application server instance in the current user plane path. So this is just one example of how artificial intelligence is helping to further optimize the edge computing use cases. And I'm pretty sure that many new use cases would also emerge.
Well, thank you very much for this, Punit. Suresh, over in SA6, you might have a different perspective on this, or you may have seen other things come across your desk. Any thoughts on this?
Yeah, thanks, John. I don't disagree with what Punit says, but when I look at the question, I kind of want to put it the other way around, where, in my view, probably the edge computing can be a building block for AI and not the other way around. That's just my perspective, but of course, we can look at it the other way as well. And the reason I say this is, in the number of use cases that we have seen or I've come across is, there's a lot of talk about using edge computing to offload the data from the UV to the network, right? And for example, split rendering and things like that. And one of the areas that comes to my mind is being able to extend what already Punit explained very well on the network analytics and so on, but the ability to actually take the machine learning that happens on the device and inference models from the device to the network. So because device is only so much capable, and having edge or the compute close to the device, I think we can look at how edge computing platforms can enable such use cases where you're able to offload data from the device to the network. And this is only, AI is just one example, but there could be a lot other use cases that would benefit from such capabilities.
Thank you. That's a fascinating perspective. You can tell that there's an architectural perspective over in SA6, which gives us a whole new way of looking at it. Georg, would you like to add any thoughts from your point of view on this, on the role of AI?
I think this was perfectly answered. I mean, practically all these areas of new technologies that we are introducing now, where edge and AI are two of them, the 5G will help them to harmonize and also to work together much better. So that is sort of our task, and we saw now 2 views on that already. So we're very well on the path to getting there. Thanks.
Excellent, thanks. Okay, over to you, Stephanie.
Thank you. That was indeed an interesting perspective on AI and edge computing. So I'd like to turn now to Suresh for the next question. How can we, as a collective international community, further boost collaboration and partnerships across the ecosystem? And having answered that, what advice would you give industry verticals interested in following the work on edge in 3GPP? Thank you.
All right, so thank you, Stephanie. So a simple answer to this question, I would say, is you need to just come and participate in the working groups in 3GPP. I mean, that's the most efficient way of doing things. Of course, I think Georg, explained very well on, our experience or, our history of working with several organizations where there is interest, and that continues to happen. We are cognizant that, all the ecosystems are important. And if you look at the slides that I presented, we are having a good relationship with GSMA, with ETSMECH in terms of, trying to harmonize as much as possible. Obviously, the composition of these forums are a little different. 3GPP, we have a global representation, whereas some other organizations, what I've seen, are regional. So that is always going to be a challenge, but I would just say that we try to do our best, and the simplest way is for the industry verticals to engage in the work that we do, and that's the most I would say the efficient way of taking the requirements on board.
So making sure everything channels towards a global organisation, indeed. I don't know if Georg or Punit would like to add to that, any of those comments?
Yeah. I think this is exactly how Suresh said. The music is playing on the floor of the working group meetings, and this is where people need to go. I mean, we can talk a lot on management level, and it's very important to do that to get an overall view. But in the end, the details of the technologies that we create have such an impact, not just that 3GPP creates, but all the other standards organizations as well, that it's really important the experts are in the room and work together. And also, I mean, being present, I mean, nowadays, thanks to the pandemic, it's not so easy, but this work will obviously continue, not just in release 17, but we will work further on edge computing also in the next releases. The coffee breaks, let's say, the social interactions between the people, especially with people that maybe work on completely different issues in 3GPP rather than edge computing, is very, very helpful, shows new synergies and so on. So I think the best way to push this work forward is really to look into the technical work that's going on, and to contribute to it. Even if it's small things, small steps bring us often quite a lot forward.
Yeah, I couldn't agree more with both Georg and Suresh. I think the best way is to get engaged with all the meetings happening virtually. I think the travel shouldn't be an issue, and it's the best way to contribute in 3GPP, being a contribution-driven organization.
Thank you. Well, if there are no further comments, I'll pass the floor back to you, John.
We are fortunate enough to have a question arising from one of our MRPs at the 5G ACIA on manufacturing, and they have a question for us saying, well, now in the future, findings from the 5G ACIA edge studies may bring in new 5G industrial edge use cases and requirements, which may require updates to these documents I am mentioning here in the question that I posted. So is there a possibility that 3GPP might add a separate document on edge use cases and requirements for various verticals? Let me start with Georg on this, who probably has the best overview, and then we can ask Suresh and the others.
So the question is mainly on the requirement side. So what's happening in SA1, because these documents that we see here are under SA1 control, where usually the work from vertical starts on with requirements and use cases. We're developing our specifications also with the releases further. So every release, all of these specifications can be extended, amended, and so on. So we see many specifications where we put in new functionalities. So changing existing specifications with new functionalities, for example, in release 18 or 19 or later on, that isn't a problem, as long, obviously, as everybody in the room agrees to go forward with that. So that is the one way. If we will have a dedicated specification on certain issues, as it said, for example, here, edge use cases from different verticals, let's say this sounds very good, but I wouldn't promise that at this moment. And why wouldn't I do that? First of all, again, it would be the decision in the room, in the SA1 room. But also, we often see this, that people come with certain ideas to 3GPP, even from an MRP, and say, we want a specification about this. But then during the discussion, we see the request is actually much more generic and can be handled in a way that is maybe independent either of edge computing or independent of the 5G ACIA, because it involves more technologies. It involves also more MRPs, such as 5G or others. that are interested to work on that. So here, I think the starting point should be to go to SA1, say, look, these are the use cases we've worked out. How is the best way to handle that? And there are experienced people in the room, also from 5G ACIA, that for sure can give good guidance on how to approach this further in the upcoming releases. Thanks.
Thanks very much, Georg. Suresh, Punit, any advice from the perspective of your working groups?
Yeah, I mean, I can maybe go first and Punit follow, but yeah, generally, as Georg said, we would love to see specific service requirements starting with SA1. It makes our life very easy. But if you ask me at the moment, at least in the work from SA6, largely has been sort of architecture driven. It wasn't really specific to particular vertical requirement as such. So we started working from an architecture level as to coming up with requirements that companies see and trying to architect an edge computing platform at the application layer. But if there are specific service requirements, I think it may be a good idea to have a dedicated document or a WID for edge computing, and I think we will all welcome that. Now, talking about a document about use case and requirements, I would rather say maybe at this point, what I feel would be very valuable is, given all the work that's happening, in SA6, SA2, and other groups, perhaps there could be a sort of a unified report from 3GPP as far as the work that we're all doing, because it's highly complex for people to navigate different working groups. So we could consider maybe a technical report where we could kind of document all the work that we're doing. So there's a single piece of document that people would then go and look at it. I know it's not part of the exact question, but it just occurred to me that could be one way to serve the verticals.
Yeah, just pretty much want to echo what Suresh and Georg has said. I mean, it would be really nice to bring such new use cases or requirements, into SA1, which is a service requirement working group. Then those can be discussed, and the best possible way, whether to have a separate document or whether to, have a separate annex in one of the existing specifications and things like that can be discussed. So again, coming back to the previous point, right? Okay, it would be really appreciated if verticals can engage and basically bring their proposals, and we have very well defined process in 3GPP, and we'll definitely be there to help you in navigating those different working groups. Thank you.
Great, thanks very much. Sounds like SA1 is the go-to place for for this sort of thing to start with, at least. So over to you, Stephanie, for the last question.
I've got another question. It's also from the 5G ACIA. With reference to TR 23748 and 23758. The question is, does 3GPP have a plan to move forward towards a solution architecture document for edge computing for different verticals, which I think we've kind of touched upon in that last discussion. But if yes, so how could 5G ACIA edge computing use cases, requirements, and architecture outcome collaborate with SA subgroups? I think we've just touched upon that with this when we were talking about having a unified report. I don't know if there's anything else you want to add there, Punit or Suresh.
Yeah, let me start. I think basically we discussed, both me and Suresh talked about some of the specification work which is ongoing. So TS 23548 is being produced by SA2 and 23558 by SA6, which describes mainly the solutions both at the network and then application layer. I mean, originally SA2 had a plan to put together a 900 series in TR. That only difference is when we do a 900 series TR, it's kind of a informative, but it's maintained. So it has a more better status in terms of the other technical reports, which are mainly for the study purpose. And the purpose of that 900 series TR was to look into various deployment scenarios for edge computing, you know, and you know, from the various different vertical you know, segments. Unfortunately, during release 17 prioritization discussions, you know, I mean, that part was dropped from release 17. I'm not sure. I mean, Suresh maybe can talk about if they have any plan in SA6 to define some of these deployment scenarios. But in a very short, yes, there was a plan. Unfortunately, you know, there was too much work in release 17, and that part of deployment scenario got deprioritized. But definitely we'll come back in release 18, or you know, we'll look into another, you know, how to basically accommodate that, you know. Suresh, do you want to add anything if you have any plans?
I think on this question, probably what I would say is we have a study on factors of the future, and I believe there is a lot of relationship with the work that we do in FFAP, or factors of the future, and you know what 5G ACIA is looking at. So far, what we have done is, you know, we are studying, and you know, the good news is the study will complete in next month, and then we start looking at normative work. So if we want to kind of bridge, you know, the work of, you know, industries into, you know, the edge platforms that we have, probably, you know, this work can be started when we start the normative work starting in July. So if there's any input you can offer, you know, it would be welcome, and the timing is not too bad. So I would say that you need to look at what we have in the factors of the future study, and when we start the normative work, you could, you know, participate in the normative work.
Thanks very much. Yeah, all of you. Yeah, I think that's just some really nice pointers there, not only for the 5G ACIA community, but I think more broadly across the vertical industries, which is always our focus point.
And so there's the question, what is the relation between edge computing standardization, I guess, in 3GPP, and open source activities like LF Edge? We haven't looked into that actively. Having said that, we have good experience with collaborating with open source project from 3GPP side. For example, the ONAP on the orchestration and management side, where we have collaboration with SA5. So we're not shy of that. People need to bring that in. Those delegates, those companies that are interested in such work will really need to highlight that to 3GPP. And then there was another question on the major challenges on enable 5G 3GPP standardization on edge computing. Well, I can only give my personal opinion, but I think the biggest challenge in the whole thing that we're doing in 5G and edge computing is just part of it, is to get the right people in the room. And that there are many people on the outskirts who are thinking of using our technologies, and we really need to address them. I know I repeat this again and again, but this is the most important thing for us, to get the experts and the expertise in our room to make solid solutions. Thanks.
Excellent. Thanks very much. Now it's time, after all this talk about standardization, we would like to get your opinion going away. Do you see the need for new areas of standardization for edge computing? Is there something that's missing? After listening to these two webinars, how do you see the situation going forward? A very interesting result is that although the majority does think yes, there is quite a few people who really don't know yet. So that means we still have a lot of education ahead of us so that people understand what the issues are and can understand what needs to be done. So thanks very much for sharing your opinions with us.
Yeah, thank you, everybody. So if we could just ask each panelist to give us a quick wrap up of today on their main takeaways. We can start with Georg and then Punit and then turn to Suresh. So Georg, what would be your takeaway?
Yeah, thank you. So from what I heard already on Tuesday and also what we saw then today in the questions, I think we are on the right road. We're doing the work that seems to be of interest for the involved parties, but it's also very clear we are. This is only just the beginning, and the potential that edge computing has in the future, that we will just see how diverse the applications are that then really are deployed. And so my feeling is this is a starting point, and we will have to work on edge computing in a very positive manner over the next years and next releases. And that also maybe answers one of these questions that is still open. From my perspective, this is also something that obviously needs to be part of whatever 6G will be. Edge computing will not go away from that. So it's a major building block of mobility in the future. Thanks.
Thank you. So let me just add earlier, I fully agree what Georg said in last comment, that edge computing is one of the key building blocks in 5G system, and it will continue to evolve in future releases. What we have seen started from release 15 and works continued in release 17 and probably beyond. One of the key is always basically having folks engaged. One of the challenges which we have in 3GPP, especially in SA2, is that we have too much work to fit it in one release cycle. And that's why we have to go through an excruciating, painful exercise of prioritization every release. As a result, some of the projects which does not get a major support kind of drops down from a release. And that's why it's really essentially for the verticals to be continue to engage and being a steward for the projects which they see is essential for their vertical segment. And last, but I'd like to also thank John and Stephanie for this wonderful webinar and very informative discussion with my colleagues, Georg and Suresh. Thank you very much for the opportunity.
Many thanks to you. Thank you, Suresh.
Yeah, so I would agree with what mostly what Georg and Punit also said, and I think also that it's a work in progress. So if you are thinking it's too late to join, please don't worry about that. It's actually a perfect time. It's an exciting subject, and there's a lot of interest we are seeing in this work. So I really encourage the vertical industries or users to get plugged into the work that we're doing and provide your requirements. I'm sure we will find solutions. And yeah, this particular webinar also I find it very useful, and I hope you have more information than you had before the webinar. Thank you.
Yeah, I agree. I think it's been an extremely informative webinar, and I'd like to extend congratulations to all of the people involved in this work in SA on edge computing. You're doing a marvelous and very important job. John, if you'd like maybe to say a final word.
I have learned more than I knew before I started this webinar. So it has been, I think it has been a fascinating webinar. And as always, we've heard from some very, very competent people from the 3GPP.
Yeah, I totally agree with that. Thank you so much for taking time to bring in your expertise. It's very much appreciated. And we know you're very, very busy. So we wish you also the very best in the future work that's coming up in the next few months. So thank you, everybody. And thank you to our audience. Thank you for joining us. We'll make sure that you get all of the information so you can take a closer look. And with that, also, we wish you also to still be careful, because we're still in lockdown and at risk health-wise. So thank you again, everybody. Okay, bye for now. Bye-bye.